Albert Einstein, a name synonymous with genius, revolutionized our understanding of the universe. In the early 20th century, he introduced the world to the theory of relativity, a groundbreaking concept that reshaped how we think about time, space, and gravity. Let's travel back to 1905, a year often referred to as Einstein's miracle year. It was during this time that he published 4 groundbreaking papers, one of which introduced the special theory of relativity. This theory began with a simple, yet profound question. What happens when you move at the speed of light? Before Einstein, time and space were seen as separate entities, but special relativity showed that they are intertwined, forming what we now call spacetime. In Einstein's view, time doesn't tick away uniformly for everyone, everywhere. Instead, it's relative. The faster you move, the slower time appears to pass. This concept is famously illustrated by the twin paradox. If one twin travels through space at near light speed while the other stays on Earth, the traveling twin would return younger than their sibling. This isn't science fiction. It's a direct consequence of special relativity and has been confirmed by experiments with atomic clocks on fast-moving planes and satellites. But Einstein didn't stop there. In 1915, he expanded his ideas with the general theory of relativity, which offered a new way to understand gravity. Before Einstein, Isaac Newton's law of universal gravitation was the accepted model. Gravity was a force that attracted objects to one another, but Einstein saw something deeper. He proposed that gravity isn't a force in the traditional sense. Instead, it's a curvature in the fabric of space-time itself. Imagine space-time as a stretched-out rubber sheet. When you place a heavy object, like a planet, on this sheet, it causes a dip, and smaller objects, like moons or satellites, naturally roll toward it. This is how gravity works according to general relativity. Massive objects like planets and stars warp the space-time around them, and this curvature guides the motion of other objects. This idea was so revolutionary that when it was first proposed, it seemed almost too strange to believe. Yet, in 1919, during a solar eclipse, astronomers observed the bending of starlight around the sun, confirming Einstein's predictions and catapulting him to international fame. The implications of general relativity are profound. It explains the behavior of planets and stars, predicts the existence of black holes, regions of space where gravity is so strong that not even light can escape, and even describes how the universe itself is expanding. One of the most mind-bending predictions of general relativity is the possibility of time travel through wormholes, hypothetical shortcuts through space-time that could, in theory, connect distant points in the universe. Einstein's theories also led to the development of technologies we rely on today. GPS satellites, for example, must account for the effects of both special and general relativity to provide accurate location data. Without these adjustments, the system would quickly become inaccurate, and our navigation devices would fail. But Einstein's work goes beyond equations and scientific theory. It challenges our very perception of reality. It forces us to rethink concepts that seem so fundamental. What is time? What is space? What is gravity? Through relativity, Einstein showed us that the universe is far more complex and beautiful than we ever imagined. As we continue to explore the cosmos, Einstein's theories remain at the heart of our quest to understand the universe. They guide the search for gravitational waves, ripples in space-time caused by violent cosmic events like colliding black holes, which were first detected in 2015, a full century after Einstein predicted them. So, the next time you look up at the night sky, remember that the light you see has traveled across the curvature of space-time, taking paths shaped by the gravity of stars and galaxies. Thanks to Einstein, we see the universe not just as a vast expanse of space, but as a dynamic, interconnected web where time and space dance together in a cosmic ballet. If you're fascinated by the mysteries of the universe, please like this video and subscribe. There's so much more to explore together.